You know, I was sitting here just a moment ago, looking at the coffee mug in my hand, then at the microphone, then at the soundproofing on the walls, and it hit me.
What hit you, the caffeine?
No. The realization that absolutely nothing around us right now is natural. Every single object in this room, the chair supporting my weight, the silicon chips recording our voices, it all had to be imagined first. It didn't exist, and then a human being decided it should exist, and they willed it into reality through engineering.
It is easy to take that for granted. We walk through modern life surrounded by what is essentially magic, but we just call it infrastructure and complain when the Wi-Fi is slow.
Exactly. We've become numb to the miracle of it. So today, I want to strip back that numbness. I want to take a journey through human ingenuity. Not just the cool gadgets, but the absolute titans of engineering, the things that defy gravity, the invisible revolutions, and the machines operating right now that honestly feel like they fell out of a sci-fi novel.
I'm in. It is a pretty wild arc when you think about it. We went from banging rocks together to create a sharp edge, to splitting the atom to create energy, in a relatively short span of cosmic time.
Insane is the word I'd use. So, let's start with the giants. When people hear engineering marvel, they usually think big. They think of the pyramids.
Which makes sense. The Great Pyramid of Giza was the tallest man-made structure for something like 3,800 years. That is a staggering reign of dominance. But that was what I call brute force engineering. It was millions of tons of stone moved by sheer muscle, leverage, and a lot of time. It's impressive, but it's heavy.
Fast forward to today. We aren't just stacking stones anymore. I remember standing at the base of the Burj Khalifa in Dubai, looking up, and my brain physically couldn't process the scale. It looked like a glitch in the simulation.
808 meters, over half a mile high. But see, the marvel there isn't just that they built it high. The marvel is that it doesn't fall over.
Because of the wind, right? At that height, the wind must be ferocious.
It's not just a breeze, it's a chaotic force. If you built a square box that tall, the wind would create these rhythmic vibrations, vortex shedding, that would eventually snap the building in half. So the engineers didn't just fight the wind, they outsmarted it. They used a buttressed core design. If you look at the footprint, it looks like a tripod or a desert flower.
So, it breaks up the wind?
Exactly. The shape forces the wind to swirl around the building at different speeds and pressures. It confuses the wind, so it can never organize into a single force strong enough to push the building over. It's engineering jujitsu, using the opponent's energy against them.
I love that. Intelligence baked into concrete. But marvels aren't always about going up. Sometimes they are about connecting things that nature put a continent between. I'm thinking of the Panama Canal.
Oh, absolutely. That is a completely different beast. Before that, if you wanted to get a ship from New York to San Francisco, you had to sail all the way around South America, around Cape Horn. It was dangerous, freezing, and incredibly slow.
So humans decided to just cut a continent in half.
In theory, yes. But they couldn't just dig a ditch because the land in the middle was higher than the ocean. So they built a water elevator.
A water elevator for massive cargo ships.
Precisely. They engineered a system of locks that uses gravity and water pressure to lift these titanic vessels 85 feet above sea level, sail them across a man-made lake, and then lower them down gently on the other side. It didn't just change shipping, it rewrote global economics overnight.
It's the scale of ambition that gets me. But here's the thing. I'd argue that the greatest engineering marvel of the last century isn't a building, or a canal, or a rocket. It's something most people have never even seen with their naked eye.
I have a feeling you're going to get microscopic on me. You're talking about the transistor?
I am. The tiny, humble transistor.
1947, Bell Labs. It changed everything. Before that, we had vacuum tubes. They were the size of light bulbs, they got incredibly hot, and they burned out constantly. The first computers took up entire rooms just to do math that a greeting card can do today.
And the transistor is basically just a switch, right? It turns on or it turns off. It sounds so boring.
Laughs. It does sound boring until you realize that on and off is the language of logic. It's binary. And because of Moore's law and some insane nano-engineering, we've gone from one clunky switch to fitting billions, literally billions, of them onto a chip the size of your fingernail.
That's the part that breaks my brain. The phone in my pocket has more computing power than NASA used to send people to the moon.
Millions of times more. And it's not just about power, it's about convergence. Think about what the smartphone actually did. It was an extinction event for other gadgets. It killed the camcorder, the GPS unit, the MP3 player, the flashlight, the calculator. It swallowed them all and put them behind a piece of glass.
And it connected the entire human species. That's the marvel part. It's not just the silicon, it's the network effect. We built a digital nervous system for the planet using these microscopic switches.
It is the ultimate example of engineering getting out of the way. When you use your phone, you aren't thinking about electron flow or logic gates. You're just thinking, I want to send this photo to my mom. The complexity is invisible.
Which brings us to the present. We've covered the big stuff and the small stuff. But what about the weird stuff? The bleeding edge. I feel like we're living in a time where the machines are starting to surpass our understanding of them.
If we are talking about the absolute peak of modern complexity, we have to talk about what's buried underground in Switzerland, the Large Hadron Collider.
My favorite machine on Earth. It looks like the interior of a spaceship from a blockbuster movie.
It really does. It's a 17-mile ring of superconducting magnets. They chill these magnets to a temperature colder than deep space just so they can accelerate protons to 99.99999% the speed of light.
And then they smash them together. It feels destructive. Why build the most expensive machine in human history just to crash particles?
Because it's a time machine, eh? When you smash protons that hard, for a fraction of a nanosecond, you are recreating the conditions of the universe right after the Big Bang.
So it's engineering designed to answer philosophy.
Exactly. It discovered the Higgs boson, the God particle, which explains why matter has mass. Without that machine, we're just guessing. With it, we're reading the source code of reality.
Incredible. Now, while the collider looks inward at the smallest things, we have another machine that's looking outward at the biggest things, the James Webb Space Telescope.
The JWST. Now that was a terrifying engineering challenge.
Why terrifying?
Because of the distance, the Hubble telescope is close enough that we could fix it if it broke. James Webb is 1 million miles away at a gravitational sweet spot called L2. You can't send a mechanic there.
And it had to fold up, right?
Right. The mirror is the size of a tennis court. You can't fit a tennis court inside a rocket, so they had to build it like origami. It had to launch folded up, travel 1 million miles, and then unfold itself in the vacuum of space with perfect precision.
If one pulley snagged,
it becomes a $10 billion piece of space junk. There were over 300 single points of failure. If any one of them went wrong, the mission was over.
But it worked.
It worked perfectly. And because it sees in infrared, it can look through dust clouds. It's showing us galaxies forming at the dawn of time. It's rewriting astronomy textbooks literally every week.
It's amazing how we use tools to extend our senses. Webb is our eyes. The collider is our microscope. But what about our bodies? I've been watching those videos from Boston Dynamics.
Oh, the robots doing parkour?
Yes, Atlas doing backflips. It's impressive, but it's also a little unsettling.
It represents a massive shift in robotics. For decades, robots were dumb. They were great at welding a car door in a factory, but if you moved the car door 1 inch to the left, the robot would still weld the empty air. They were blind scripts.
And now?
Now they have dynamic balance. They are sensing the environment in real time. If you push Atlas, it stumbles, corrects its center of gravity, and regains its balance, just like a human would. When you combine that physical capability with the AI brains we are developing, things are about to get very interesting.
That's the horizon, isn't it? We've mastered static structures, we've mastered electricity, and now we are trying to master intelligence and autonomy.
The gap between science fiction and engineering reality is shrinking. I mean, look at what's next. We are chasing fusion energy, basically trying to build a star in a bottle. If we crack that, we have limitless clean energy.
And the other big one?
Artificial general intelligence. AGI, a machine that can engineer better machines than we can.
That's a heavy thought. Once the machine becomes the inventor, what happens to the human engineer?
Maybe we become the curators. Or maybe we just enjoy the ride.
It really reinforces the idea that humans are, fundamentally, tool makers. That's our superpower. From the stone axe to the James Webb, It's all just a continuous line of us trying to extend our reach.
Winston Churchill said it best, "We shape our buildings, thereafter they shape us." The same is true for all our technology. We build the tools, and then the tools redefine what it means to be human.
That is a perfect place to leave it. A little bit of philosophy to go with the physics.
Always.
Thank you for taking this deep dive with me. It's been a wild 15 minutes.
Anytime. It's good to look up from the screen once in a while and appreciate how the screen got there.
Indeed. And to everyone listening, keep wondering and keep building. We'll catch you in the next episode.